These playful animals have added another chapter to man's knowledge of the universe in which he lives. They have helped pave the way for the next step in the future, the transportation of humans by rocket into the limitless region beyond our atmosphere. The successful recovery of nose cones fired on Jupiter missiles over a 1,500-mile range by the U.S. Army in 1958 prompted a request by the Surgeon General of the Army to include a series of biological experiments in future nose cone recovery missions. From information previously gained by the Army from the huge missiles fired into outer space, it seemed almost certain that living things could survive the trip and safely return to Earth. Several recoveries of nose cones had proved the reliability of the recovery equipment and had given Navy personnel training in locating and returning the cones. With the National Aeronautics and Space Administration sponsoring the scientific experiments, the Army and the Navy started a testing program to select one South American squirrel monkey and one rhesus monkey, American-born, to take the trip through space. Monkeys were chosen since they closely resemble man in many ways. Their reaction to the flight would help measure man's capability to travel by rocket. The monkeys' training included their conditioning for the time required to make the rocket trip and await recovery. Thus, they would not be unduly excited when the actual flight was to be made. At the laboratories of the Army Ballistic Missile Agency in Alabama, the nose cone and recovery equipment were checked and prepared for the historic flight. Enough room was available so that two monkeys could be placed in the cone. The Army's scientists and technicians built the capsules and equipment for the small passengers. This capsule for the larger of the two monkeys was carefully fitted to its supports in the missile cone. All possible tests were conducted to ensure the well-being of the travelers. These included placing the capsule in a container, sealing it airtight, and checking for any leaks. In the void above the atmosphere, all the equipment must work properly. Oxygen was pumped through the lines and pressure tests were made. Exhaustive tests proved that the container would furnish life-giving oxygen to the passenger and would remove carbon dioxide. It would also maintain the proper temperature, humidity, and air pressure. Full tests were made to find out if the capsule would operate properly when installed within the cone. During the flight, information on the animals would be sent to ground stations by radio signals called telemetering. While scientists prepared the experiment, work was in progress at the Army Ordnance Missile Command, where the Jupiter missile was built. The addition of the experiment was incidental to the scheduled development test of this weapons system. The two containers for the monkeys were fitted in unused space in the nose cone. On the left, containers can be seen in position within the cone. The large monkey is in the center. The small squirrel monkey is at the base of the cone. The chart on the right shows the large capsule. When all equipment was functioning, the time had arrived for live test of the system. The rhesus monkey, sealed in a contour-fitting chair, was placed in the capsule. The capsule was sealed. Air was supplied through the oxygen lines that would be used during the flight in space. The monkey could be seen through a porthole in the container. It was unconcerned as its reactions to its artificial environment were recorded for further detailed study. The monkey's heartbeat and other bodily functions were little affected by the confinement and artificial atmosphere. He was not even excited by being confined. The careful training had served its purpose. The experiment could proceed. The instrument compartment of the missile containing the guidance, controls, and telemetering equipment received a checkout which included a test of the capsule. After the testing of the larger container and its passenger, the scientific experiments were ready. The monkey was now removed from the capsule. He would continue to receive environmental conditioning until the scheduled missile firing date. Meanwhile, the small squirrel monkey was being readied for the same trip. A smaller, simpler capsule was provided which would serve as a backup to the experiment in case there should be any mishap with the more complicated equipment for the rhesus monkey. In December, a 1958 Jupiter missile firing, a squirrel monkey had traveled through space. It survived the trip beyond the atmosphere, although it was not later recovered. The same type of capsule was used. The box was insulated with foil and fiberglass for protection against sharp temperature changes. The smaller monkey was similarly fitted in a container. Instruments were added to the capsule to record his reaction. Instruments to record the monkey's physical reactions during flight included this oscilloscope. The moving line indicates the physical reaction of the monkey during testing of the equipment. With the small animal comfortable in its container, the assembly was packed into a framework that would fit into the environment-controlled capsule. As with the larger monkey, this one was also sealed. Air would be supplied by the lines used during the actual test. Preparations for the passenger were now completed. Major Gerald A. Chaplin, Chief of the Bioastronautics Research Unit, Army Ordnance Missile Command, and Dr. Siegfried J. Karachwal, Chief Scientists and technicians, meticulously checked each part of the experiment before giving final approval to continue. All indications were that the animals could survive the trip over 300 miles above the Earth, traveling with only slight, if any, discomfort. The two travelers received excellent care while awaiting to be moved to the Florida missile firing site. At the missile firing laboratory at Cape Canaveral, the Jupiter missile was rechecked upon arrival after being flown from the development center at Redstone Arsenal. No difficulties were encountered. A few days before the firing, the Jupiter was moved to the launching pad and erected. It was another test of the weapon developed by the Army Ordnance Missile Command for use of the Air Force. Before the firing, the passengers were given complete medical examinations. A mobile biological laboratory was installed in a van which housed the monkeys near the launching pad. As the firing time approached, the monkeys were readied for their historic journey. A final check was made of all equipment. Wires were connected to the helmet, chest plate, and chair to return to Earth during the flight the scientific information that was needed. Firing preparations continued. With the animals in place, the nose cone was smoothly raised to the top of the missile. The passengers were sealed within the containers, the air supply and other environmental needs being constantly watched by the medical personnel. Information from this experiment will help to provide a more complete understanding of man's responses to space flight. How will the human body react to confinement and in isolation in a space capsule? Can an artificial atmosphere for animal life be provided? What is the reaction to high accelerations and decelerations, noise and vibration? A contribution is being made to the development, safety and efficiency of manned space flight. The planned missile trajectory during this test would terminate as the parachute lowered the nose cone gently to the ocean. Electronic signals guided waiting ships quickly to the exact landing spot. After the Jupiter lifted above the atmosphere, the motor cut off. Soon, the empty fuel tanks and motor were separated from the nose cone and instrument compartment. After the guidance and controls had placed the cone at the right speed and position to reach the target, this instrument section was also separated. Small controls within the cone tilted it to the proper position for re-entering the Earth's atmosphere. After re-entry, the base plate of the cone was discharged. A parachute opened, which slowed the cone enough for a larger chute to operate properly. Both chutes now floated the cone gently toward the water of the Atlantic Ocean. A buoy was next ejected and inflated to mark the landing spot. As the cone re-entered the atmosphere, the friction of the air slowed the cone's velocity. The nose cone was so constructed that the 5,000-degree heat of the re-entry would not be felt on the inside. The subjects were kept relatively cool during the historic flight. As the cone entered the water, the heat from the surface of the cone caused clouds of steam. To ensure immediate recovery, the floating cone was equipped with flashing lights and a radio transmitter which transmitted continuous signals. During the hours of darkness, the powerful Jupiter lifted off the ground and started on its journey to arrive some 1,500 miles away in a short 15 minutes. As you know by the time you view this film, the successful recovery of the nose cone with its live cargo has placed man another step forward in his plan of making rocketry another means of transportation for man. Science has passed another milestone.